So I have in front of me a multimeter. This is like a $12 multimeter off Amazon. It's like the cheapest one you can buy. You can buy them very cheap. They're common. They're everywhere. It's not too bad. What is it? So a multimeter. Why is it called a multimeter? Because of the word multi. It does multiple things. I actually didn't realize this until recently. That's why. It's pretty simple. It has really three tools in it. It has what's called an ammeter. Ammeter, I don't know if I spelled that right, for measuring current. It has a voltmeter for measuring volts. And this version actually has a voltmeter for direct current and a different voltmeter for alternating current. Most of them do. Now the little squiggly here, I don't know if this little sine wave indicates that this is the alternating current, and this is the direct current side over here. And lastly, it has an ohm meter, which measures resistance. And so if you look at the face of the device, you will see here's volts. This is alternating current volts. Over here, A indicates you have amps. Amps, it only does direct current, and you can see the direct current kind of line looks like that versus the alternating current. So this is AC, this is DC. There will be another video that you'll be able to watch on this. Maybe I'll figure out a way to put a link in here. So this is the ammeter here. There are some tools for something called continuity testing, which we'll talk about in a second. Here's the ohm meter here, which measures resistance, and over here is the direct current of the voltmeter. It's important to know, I've blown 100 fuses in these things. You're going to blow some fuses. They're very cheap. You can buy new ones at Home Depot. There's two fuses inside of this thing. And so when you look at these cables here, essentially one is a positive, one is a negative. This mode over here is for measuring primarily low currents, but it can do high voltages. And then you have a mode over here where you can switch this switcher connector, and you can do higher currents up to 10 amp max. If you do high currents on this mode, you'll blow out the fuse. And so you'll see they usually put the fuse rated on here. So this is 500. I don't know if you can see it on here. This is 500 milliamps max. Is the maximum amount of current you can put on this connector. If you put more than that, it'll blow the fuse and it won't work, and you'll have to buy a new fuse. If you can buy fuses at Menards or Home Depot or whatever. They're very cheap. They're very common. They're not a problem at all. So, and on this side, there's another fuse over here. I don't know if they tell you what the rating, I guess, is 10 amp max. If you put more than 10 amps through, you'll blow the fuse on this side too. But on this side, you can measure high voltages, just you can't put current through it. So let's talk about what that means specifically. So behind the scenes, like what's going on inside of an ohm meter. So on the voltmeter side, it essentially has a large resistor. In here, it's got like, I don't know, a resistor. Here's an example of what a resistor looks like, right? It's got a resistor like this, but it's got one that's like 1,000,000 ohms. And so what that means is that no current will flow, but there will be a voltage differential. So you can measure very high voltages as long as you're in the volt mode. Uh, and essentially no current will flow because it's using a very high resistance resistor. So that means you can do things like you could measure AC mains if you want. And so like sometimes I'll use this if I'm doing work around the house and I want to say, well, like, is there a circuit active or something? So I've got here just an active AC mains. And if I was to put this in ammeter mode and plug it in here, it would blow the fuse. It would short out the circuit, probably blow the fuse here and trip the breaker. But what I can do is I can do in voltmeter mode, I can go to AC volts. This is 120 AC. And so I've got my electrodes here, and you can pop them right in. Boom, boom. And you might be like, Tom, why are you not getting electrocuted right now? Why is it not shooting sparks and killing you? Well, it's because there's a 1,000,000 ohm resistor behind here, so there's no current flowing through. If I snap this into the A mode over here, it will short out, but you can see there's 125.8 volts of alternating current. And that's what flows in your wall here. And if I went to the DC mode, I won't do it. I don't want to turn it while it's on high voltage. But like if I went to the DC mode, you would see it would basically read 0 because it's alternating. So let's unplug this. Oops, that's not good. Let's take this one out first. There we go. Take these connectors out. It's not good. Let's unplug this. So, all right. So now let's change the connectors here. So these electrodes that I have here, where's this one? I want to just come on, connect it. There we go. So these connectors I have here are, disconnect those. You can replace them, and there's nothing special about them. Hold on, I'm trying to get this thing disconnected. Let's just try to figure out a way to edit this part of the video out if I can. If not, doesn't matter. So you can replace the connectors with any other kind of connector. So over here I have another type. So you'll see here are two more connectors. They can go in here, and we can now just measure anything we want. So I've got like a DC battery, right? So we're still in AC mode. So watch what happens when we try to get the AC voltage. So we're trying to get the AC voltage. You actually notice it saw a voltage at first, but then it went to 0. We'll talk about that in a different video. But watch, you can slip it over to here, and we'll see. This should be a 9-volt. Oh, it's not plugged in. This is a 9-volt DC battery, and you will see it registers 8.6 volts direct current from this battery. So that's fine. That's what you'd expect. It's usually I've used a little bit of the battery, so it's not totally 9 volts. You can try other things. Here we've got like a supercapacitor, and if I just measure across, you'll see it's about 2.5 volts. This thing charges up to 2.7, so it's pretty full. I've got solar panel here, so like we can connect this. I've got this like little micro solar panel. We can connect that to the connectors here, and you will see that it will register a voltage of about 5 volts. It's negative. I could flip the connectors, but it's about 5 volts. And if I put it in more light, we'll see. I'm putting it in some sunlight now, 7 volts. But again, there's no current flowing through because this is just in the voltmeter mode. So let's talk about the ammeter mode now. So in the ammeter mode, you can measure the specific amount of current that can flow through. So keeping it in solar is actually a good idea. So we'll put this over here. So right now in solar, we're in sort of half direct sunlight, and you'll see it's about 6.5 volts. And so we can switch this to ammeter mode, and we can see not very many amps, right? So it looks like about, if you look here, it looks like it's about 1 milliamp. We're in sort of 20 milliamp mode here, which is, this sort of specifies the peak, and we're less than 1. The sun just kind of moved, and you saw it changed, or my arms move and block the sun. And so we could even do the math here if you wanted to, right? So you could say, well, 1 milliamp is not very much. So the voltage from this, what's the voltage? The voltage from this was about, V was about 6.5 volts. And you can see, total power we're getting out is, our current is about 1 milliamp, which is 0.001 amps. So you can see the total power we're getting from this little solar panel is a watt. If you remember, this is another equation. Perhaps I'll make another video on this when we talk about power. You may remember watts are volts times amps, right? So when we multiply volts times amps, we get a pretty small number. So if you think about power, you think about like 100-watt stereo or something like that. This is a very, very small amount of power. Cool. So that is ammeter mode. So ammeter mode you should not do if you're going to short. It's okay to short something when it's less than 50 milliamps. But if we were to do something like my supercapacitor over there, it'll discharge 200 amps. This super cap right here will discharge 200 amps at once. It would blow both of those fuses out. So we wouldn't want to use this one in ammeter mode. We could. It would just make a big spark and blow it out, and I'd have to replace the fuse. You can also see, so here I've got this little fan. It's this little fan, and there's a little alternating current dynamo in there. And if we plug this thing in, you can see it's alternating current. So we're going to see the current kind of bounce all over as we spin it. We can see it's measuring the current, and the current's kind of bouncing all over as we spin it. And we could go back to voltmeter mode too, and we could see, it's generating as I spin this thing. It's generating 2 volts, a little under 2 volts. And if we look at the ammeter, it's less than a milliamp. So it's not generating a ton of current, but it's small. It's just a small, tiny little handheld fan. Cool, a little tiny handheld generator. So then the last mode in a multimeter is the ohm meter mode. And what that does is that measures resistance. So we can take something like this. This is a sort of cement resistor we have here. We can attach this to both sides. And let's see, I think this resistor is rated for, it's a 20 watt max, but it's rated for 1 ohm. And if we go over here, we should see, um, it's about 1.1. That doesn't seem right. 1.1, yeah, there we go. So it's about 1.1, and again, we're in 200 mode, so 200 is the max here. So this is 1.1 ohms, so it's close enough. These things aren't built perfectly. We can try another one. I've got like where'd the little resistor go? I had that little resistor. I have another cement one here. We can try this cement one. This cement one's rated for 10 ohms, and we can see it's 10.1, 10.0. It's close enough. So these resistors are sort of rated properly. Here is a metal oxide resistor. You can see this one, I think, is 51,000 ohms. We can confirm, so it's one here, so we can go up. We can go up further, up further, up further. There we go. 50.9, so I think it's rated for 51, so it's close, right? These are not perfect. Usually there's some margin of error on the resistance that they offer, and this one appears to be off by a little bit. So that's fine though. So we could measure resistances that way. And then the last mode in here is probably might be actually the most useful one, which is continuity mode. And what it does is when it finds an electrically continuous circuit, it makes a beep. So I've got my two electrodes here, and we can connect them to, say, I don't know, my keys. Here's my keys. So let's connect it to a key here, and it's made of metal, so it should be electrically conductive, and you can hear it beeping. And it just tells you that the circuit is complete. This is useful when you're testing, like, if you've put something together and you're like, well, I need to know. And so like this is still, even though there's some resistance here, it is still electrically complete. And we can attach this and you'll see it's beeping and it's actually telling us the resistance. So it's useful when you're testing like a circuit board or something and you're like, is this circuit complete? Could current even flow at all? It's really useful to do it in continuity mode, and it beeps, which is particularly nice. Anyway, this is my lesson on multimeters. If you have any questions, leave them in the comments. Yeah, and I encourage everyone to buy one. This one's like $12, and they're fun to test around with. It's also useful to get different pairs of electrodes. These ones, I'm not sure if electrode is the right word here. These ones are really nice because they connect in and they have, these little alligator clips. Other ones have have like a pointy, other ones kind of look more like this, and they have a pointy end, which can be sometimes useful, but sometimes when you need to clip it to something, it's hard to use. Anyway, thank you, and like and subscribe. Bye.